Hi everyone and welcome to my video. My name is Sunshine A. Agbayani and I'm really glad you're here. Today I'll be walking you through an exciting topic. Whether this is your first time exploring this subject or you're looking to deepen your understanding, I'm telling you, you're in the right place. So grab a notebook, get comfortable, and let's get started. So number one, the idea of the conditioning. So let's assume 12 equally likely outcomes. So let's do. This is the event A and the event B. And then number of outcomes in A is equal to 5. So 3 only in A plus 2 in A and B. Like this. 2, then 1, 2, 3, 1, 2, 3, 4. So let's do the formula. So probability of A is equal to 5 over 12. Then let's draw other box. A and B. 3 over 12 and then 2 over 12. Then 3 over 12 and 4 over 12. And the formula is probability of event B is equal to 6 over 12. So this is the number of outcomes in B. So B is equal to 6, then 4 only in B plus 2 in A and B. And then the intersection of A and B commonly outcomes is equal to 2. These are the two outcomes in both A and B. So let's move to the... So use new information to revise a model. If told B occurred, which means your new universe is limited to the outcomes inside the B. Only the red one, region 6 dots, like this. One, two, three, four, five, six. Event B and event A. Then, this is the basis of conditionally probability. Restrict your view to V and recompute probabilities when that new view. So, the formula is probability of event A and B is equal to, then probability of B and C is equal to. Then, let's draw other box. Probability of A and C. Definition of conditional probability. So, let's draw again the other box. Event A two over 12. And then event B 4 over 12. So this one, let's recall omega. Omega. And this one, an event of interest. And then this one, another event. And this one is this represent A intersect B. And the event where both A and B occur. From the number inside, let's do the formula. So P, or probability of event A intersect Bn, is equal to 2 over 12, and then probability of B is equal to 6 over 12 equals to 2 over 12 plus 4 over 12. So the intersection plus B only outcomes. Number 3, the conditional probabilities. So written as P, or probability of A and B. So this is already the probability of A given that B has occurred. So if you already know B happened, what's the chance that A also happened? So let's do the formula. Event, probability, event A and B is equal to probability of A intersect B over probability of event B. So the numerator, this one the numerator, and then the probability that both A and B happen. And then the denominator is probability of B. So we are restricting the sample space to B and asking what fraction of B is also A. Elementary properties of expectation. X is equal to X X P X. So this is the fundamental definition of expected value or expectation for a discrete random variable X. Then this one, which is called the represent the expected value of random variable X. And then the sum, this one is the sum is taken over all possible values that x can take. And then this one is the probability mass function, the probability that x equals x. And then we must multiply each possible value by its probability and sum them all up. This gives us the average or mean value we expect x to take. So, example, if x can be 1, 2, or 3 with probabilities with probabilities 0.5, 0.3, and 0.2. And then respectively, then is equal to 1 and 0.5 plus 2, 0.3 plus 3, 0.5 0.2, then plus 0.6 and plus 0.6 is equal to 1.7. Number 5 is the joint probability mass function. P, Y, and Z, and X, Y, and Z is equal to probability of X is equal to X and Y is equal to Y and Z is equal to Z. So that defines the joint probability mass function for 3 random variables, the x, y, and z. And then this gives the probability that all 3 events happen simultaneously. Then x takes the specific value, x and y takes the specific value of y, and z takes the specific value of z. It describes the complete probabilistic relationship between the 3 variables. So, example, if x, number of red balls 12, then y is the number of blue balls and z is the number of green balls from an urn. Then P, X, Y, and 2, 1, and 0 would be the probability of drawing exactly 2 red balls, 1 blue ball, and 0 green balls. 6. The normalization property. x sum of y and sum of u, then px y u, then x y and u is equal to 1. So this states that when you sum the joint probability over all possible combinations of values, you get 1. So the triple sum covers every possible outcome. Since one of these outcomes must occur, the total probability is 1. Then this is the fundamental requirement for any valid probability distribution. Why it's true? Since the events are mutually exclusive and collectively exhausted. Exactly one combination of x, y, and u, z. So, must occur, so all probabilities must sum to 1. So, the number 7 is marginal distribution of x. So px is equal to sum of y and sum of u, then px y and u is equal to x, y, and z. This shows how to find the marginal probability mass function of x from the joint distribution. So to find the p of x is equal to x, we sum over all possible values of x and y. I mean y and z. Sorry. We're marginalizing out or integrating out the other variables. This gives us the probability distribution of x alone, ignoring y and z. We want this one, regardless of what z or y and z are, so we add up p x is equal to, or probability x and y and y. And square z is equal to z. So for every possible, the y and z pair. Then if we want to probability that x is equal to 2, then regardless of y and z values, we sum p, x, y, and u, then 2, y, and z over all possible y and z values. Number 8, the marginal distribution of x and y. So p so x and y, so that the sum of u, then p, x, y, and u, then x, y, and z. So this shows how to find the joint marginal distribution of x and y together. So this given px is equal to x and y is equal to y, ignoring what z is. We sum over all possible values of z while keeping x and y fixed. We're marginalizing out only z, keeping the joint relationship between y and x. So we want the probability that x and x is equal to x and y is equal to y. Then regardless of what z is, so we sum over all probabilities or possible z values. Then example, the pxy is equal to 2 and 1. Then would give the probability that x is equal to 2 and y is equal to 1. So regardless of what z equals. Number 9, the general CDF or the cumulative distribution function properties. So the definition is fx probability of x is equal to probability of x is equal to x. Then this is the fundamental definition of cumulative distribution function. Then this one gives the probability that are random variables x takes a value less than or equal to x. So its cumulative probability, it's accumulate all the probability up to n including the point x. So for any specific value x, and CDF tells you what function of the distribution lies to the left or that point. So example, if x represents heights of people, and x is 170 is equal to 0.6. This means 60% of people have height 170 cm. This is the actions or probability of actions. So, number 1, or the action 1 is the non-negativity. Non-negativity. The formula is probability of A is equal to 0. Greater than or less than the 0. So, the probability of any event is always non-negative. The probability cannot be negative numbers, or the minimum possible probability is 0. So, probability represents how likely something is to happen. It doesn't make interesting sentence to have negative likelihood. Example, probability of rolling a 7 on a standard die. On a standard die, I should say, is equal to 0. So, but never something like negative 0.3. And then, other one is the normalization. probability of omega is equal to 1. So the probability of the entire sample space is 1. This means something from the sample space must happen with certainty. The total probability of all possible outcomes is 1 or 100%. And then, when you perform an experiment, one of the possible outcomes in the sample space must occur. There is no other possibility. Example, when rolling a die, P getting 1, 2, 3, 4, 5, and 6 is equal to 1. Because one of these must happen. And then the number 3 is, or lastly, the finite or additivity. If A is equal to empty set, P event A union B is equal to probability of event A plus probability of event B. And then, take note, empty set is written below indicating A and B are disjoint. So what it means? If two events A and B are mutually exclusive, cannot happen simultaneously, then the probability that either A or B occurs equals the sum of their individual probabilities. So this one and this one is the means A and B no outcomes in common or disjoints mutually exclusive. And then this one is means A or B the union of the events. So if A and B cannot happen at the same time, then to find the probability of A or B, you just add their individual probabilities. There is no overlap to worry about. So yeah, that's it.